Safety gloves are one of the most universally used protective products on Earth. Worn everywhere from massive construction sites and steel mills to hospitals, food factories, laboratories, farms, warehouses, oil rigs, power plants, chemical facilities, automotive assembly lines, emergency services, and more. Yet almost nobody ever sees the enormous global industrial ecosystem that produces billions of gloves every year. And today on The How Factory, we're going deep beneath the surface to explore not only how safety gloves are manufactured at scale, but also the chemistry, robotics, engineering, environmental controls, and global supply chain that make this astonishing industry possible. The story begins long before a glove ever touches a human hand. It starts with raw materials that span continents. Natural rubber latex comes from plantations in Malaysia, Thailand, and Indonesia, where workers tap rubber trees at dawn by carving precise grooves into the bark and letting sap drip into cups. A process that has barely changed in a century. This latex is filtered, concentrated, and stabilized before being shipped in giant tanks to glove factories. Synthetic nitrile rubber comes from chemical plants, where acrylonitrile and butadiene are polymerized into a tough, oil-resistant material ideal for disposable gloves. PVC and polyurethane resins arrive for coated gloves used in heavy industry. Specialized fibers like Kevlar, aramids, basalt fibers, steel wire threads, glass fiber composites, thermoplastic elastomers, HPPE, and cooling yarns are produced in high-tech fiber mills and delivered on massive spools ready for knitting. Even cotton and polyester liners begin their journey at spinning mills, where raw fibers are cleaned, carded, twisted, and wound into stable yarns. Once these diverse materials reach a glove plant, the transformation begins inside colossal manufacturing lines that run 24 hours a day. For dipped gloves, which make up most of the world's inventory, production revolves around thousands of ceramic or aluminum hand-shaped molds called formers mounted on gigantic conveyor chains. These formers travel slowly through the entire factory, sometimes stretching more than 200 meters in length. The process begins with cleaning. Dust, oils, and microscopic residues can cause imperfections in glove films, so formers pass through steaming hot water jets, detergent baths, ultrasonic vibration tanks, and mechanical scrubbers. Sensors monitor cleanliness, and if even a trace of contamination remains, formers are automatically routed back for recleaning. After washing, formers enter preheating tunnels where they reach the exact temperature needed for optimal latex or nitrile coating. Next, they move into coagulant tanks filled with calcium nitrate solutions. This coagulant ensures the rubber binds evenly and forms a smooth, uniform glove layer. Once coated, formers travel into massive dipping tanks filled with liquid latex, nitrile, PVC, or polyurethane. As the former submerges, rubber molecules instantly cling to the surface. When it rises out of the tank, excess material drips off, and the conveyor gives the glove a perfectly consistent thickness. For thick industrial gloves, the process repeats. Second dips for reinforcement, third dips for chemical resistance layers, and special dips for grip coatings. From here, gloves move into curing tunnels. Enormous ovens stretching the length of the plant. Temperatures inside reach 100 to 140 degrees Celsius, triggering vulcanization, the chemical cross-linking that gives gloves their strength, elasticity, puncture resistance, and tear durability. Modern factories use AI-controlled curing ovens that constantly adjust heat distribution to ensure perfectly even curing across thousands of gloves. After curing, gloves pass through leaching tanks filled with warm water to remove residual chemicals and proteins, dramatically reducing the risk of allergic reactions. Medical-grade gloves undergo extra leaching cycles, sometimes lasting hours to meet strict hospital standards. Some gloves then enter chlorination chambers where controlled chlorine gas or liquid treatment makes the glove silkier, smoother, and easier to don. Others receive polymer coatings for additional comfort. For textured gloves, embossing rollers or sand spray systems create raised patterns for superior grip in wet, oily, or industrial environments. Meanwhile, cut-resistant gloves follow an entirely different production path. These gloves start with high-speed computer-controlled knitting machines capable of producing seamless gloves, with precise shaping around fingers, palms, and knuckles. These machines weave blends of HPPE fibers, aramids, nylon, steel microthreads, and fiberglass into layers that achieve specific protection ratings according to EN 388 and ANSI standards. Each yarn combination is engineered to balance flexibility, breathability, and performance. After knitting, these gloves are dipped or coated for grip, chemical resistance, abrasion strength, or impact protection. Some even receive thermoformed rubber protection pads built from TPR, thermoplastic rubber, to protect hands from crushing hazards. Once the glove shell is formed, stripping begins. Automated peeling machines use bursts of high-pressure air, rotating brushes or mechanical rollers to remove gloves from formers without tearing the thin rubber films. Gloves drop onto conveyors and head toward final drying tunnels where warm air removes moisture. Then they enter the inspection phase, one of the most critical steps in the entire factory. First, gloves undergo water leak tests, where they are inflated with water to reveal microscopic holes. Next, air inflation machines blow up gloves like balloons to detect defects invisible to the eye. High-speed cameras scan every glove for blemishes, thin spots, inconsistent color, surface bubbles, or structural weaknesses. AI algorithms identify defects in milliseconds and instantly eject flawed gloves. Human inspectors review samples to ensure machines remain calibrated. Gloves that pass inspection proceed to finishing. Disposable gloves are automatically counted into stacks using optical sensors. Tougher industrial gloves may receive interior linings, fleece inserts, antimicrobial fabrics, moisture-wicking layers, or extra wrist support bands, stitched on by automated sewing robots. Heat-resistant gloves receive long gauntlet cuffs. Impact-resistant gloves get padded armor segments applied with heat-bonding systems. Chemical gloves may be double-layered and tested individually for leaks. Now gloves enter packaging. For disposable gloves, automated filling machines load boxes with 50, 100, or 200 gloves. For industrial gloves, pairs are matched by size using sensors that measure cuff width and finger length. Boxes are sealed, barcoded, batch-coded, and sent through metal detection tunnels to ensure no foreign objects are inside. Sterile medical gloves undergo even more intense processes inside ISO-certified cleanrooms. Workers wear full protective suits as automated systems pack gloves into sterile pouches that are then exposed to gamma radiation or ethylene oxide sterilization. These pouches travel through hermetically sealed tunnels before being boxed and palletized. In advanced factories, entire packaging lines are robotic. Palletizers stack boxes with millimeter precision, while automated guided vehicles transport pallets to climate-controlled warehouses. Throughout the entire plant, chemistry labs operate around the clock. Technicians test viscosity of latex, tensile strength of finished gloves, elongation rates, abrasion resistance, puncture resistance, thermal performance, and chemical durability. Samples are stretched until they snap, exposed to acids, oils, solvents, and heat, and run through mechanical wear testers that simulate years of use in minutes. Environmental systems filter factory emissions, recycle wastewater, recover heat from curing ovens, and convert scrap nitrile into reclaimed rubber. Some plants use solar power, biogas, or energy-efficient burners to reduce carbon emissions. Water purification units ensure leaching baths remain clean. Factories track every glove from material batch to final box using digital traceability. Once packaged, gloves enter a colossal global distribution network. Ships carry giant containers filled with gloves to ports worldwide. Trucks move them to warehouses, wholesalers, retail stores, construction suppliers, hospitals, emergency departments, and e-commerce distributors. A single factory can supply tens of thousands of companies. Global demand surged during the pandemic, forcing factories to scale up production, automate further, and diversify materials. Today, the industry continues evolving. New biodegradable glove materials are emerging, recycled content gloves are entering the market, nanofiber reinforced gloves promise extreme strength and thinness, and robotic quality inspection systems are becoming more accurate than ever. What seems like a simple item, a glove, is actually the result of global supply chains, complex chemistry, automated machinery, engineering, logistics, industrial robotics, and non-stop quality control. And that is exactly how safety gloves are mass-produced for millions of workers every single day. An astonishing blend of science, technology, and industrial precision working together to protect the world's hands. Thanks for watching The How Factory, where we reveal how the world truly works. Don't forget to like, subscribe, and join us for more deep dives into the hidden processes behind everyday products.